So first of all, thank you, TACT, and thank you, David, for letting me speak here. I was at the Docs SFO 2 months back, and all of the talks are amazing. So no pressure, right? Anyways, so before I wanted to structure this talk slightly differently. I didn't want to just start with a slide and introduce myself. I wanted to start with a demo, actually. So I'm just going to go ahead and do it. What I'm going to do is launch a production-ready PostgreSQL cluster with one command on Kubernetes. And let's see. So I have a manifest file. So what I first do is create 2 Kubernetes objects. Just a show of hands, how many of you have used Kubernetes before? Heard of it? Oh, great. Everyone's used it. Pretty much. So one of the things I started noticing when I was helping various companies use Kubernetes, and also I was playing with it. I'm also a contributor on it. And one of the things I started noticing was there's a lot of complexity around it. Complexity around just understanding how it works. It doesn't follow a traditional model. The first concept you learn it in is a pod, and it's not how all the different IT systems we've been used to work. So I started working on making it simpler. So what I've done is I just used the kubectl command, which is the command line utility for controlling Kubernetes, to launch 2 resources. One is a deployment, one is a service. And what we're going to do now is look at if the services are ready. Okay, so it's ready. I'm going to copy this IP address and then go to my other screen. For this demo, I created a quick front end. I'm not a front end engineer, so let's see. All right, so what we're doing here is I created a Kubernetes object, I connected to it, and now it shows me the screen where I can configure how I want my PostgreSQL set up to run. I'm just going to leave the defaults on, and I'm going to say deploy. Let's see. Okay, so it's starting. So this is very different from the usual Kubernetes way of starting services, but this is something I'm working on. So let's just wait for it to start. In the meantime, we can go back to the command line and see if there's any new services starting. So it looks like here 20 seconds ago something started, and 20 seconds ago something else started. Let me wait for all of them to start running. Okay, so right now I've just set up a replicated master-slave distributed PostgreSQL setup, and I'm going to go over just some sort of testing around it. Like I'm just going to go into the master, and I'm going to see if it's up and running correctly. So I just exec'd into the master container, and then just going to run the Postgres command, and let's say I create a table. Create table. I'll call it replication test, and I'll put in one value called test, which is a character value. That was an error. Okay. Create table rep test. There. All right. Create table succeeded. Now what I'm going to do is insert into this table. Okay. Insert into the test values. All right. So I would like the audience to give me a small string, small character text. Anything you'd like to say? Just shout it. Docs SFO. Okay. Docs SFO, and I'm just going to insert it. insert into rep test values. I think that syntax is right.
No, it's the clear that got you.
Yeah, those semicolons.
Sorry, what? Oh, there's a clear.
Yeah,
Oh.
You're cleared there, now you're
Okay.
clear of the clear.
Okay. Great. Thank you. All right. So, great. So I've just inserted some data. This is really boring stuff. But what I'm going to do now is I'm going to go to this screen here, and I'm going to get into the slave container and see if that data showed up. Exec-it. Again. Okay. So all right. So there you see, using just one command, we set up a PostgreSQL master-slave replicated setup. And there's more you can do. Like I can scale it up. I can scale up just the entire application, assuming, let's say, the load on my application is going up. So I have a nice UI for it, and also the logs are being streamed here. Let's see. Let me set the scale to 2 and say apply changes, and let me go back and see if a new container is starting. All right, so you see pod initializing. So another instance just started up, and this just started up 12 seconds ago. If I go into it, let's see if replication's working. All right, so the same command again. Yeah, so this also has the data. So similarly, we can automate just about any operational aspect of running PostgreSQL using Kubernetes. You do not need to get a custom solution. You don't have to write homemade scripts. Everything can be automated, and that's what I'm here to talk about today. So let me get into the presentation now. There. Okay, so what we just saw was this kind of architecture where I used one command, kubectl apply-f, and I provided a manifest file. I can show you the manifest file. It's a really simple file with just 2 resources. It doesn't look complicated. It's easy to read. And that one command launched a full-fledged PostgreSQL cluster. And the way it works is it launches a PostgreSQL controller that I wrote, and that controller knows how to orchestrate how PostgreSQL is supposed to scale. It knows how to conduct failover. It knows how to read the logs out of it. It knows how to monitor it. So after doing this, I asked myself, what if this could be done for just about any application without really knowing how Kubernetes controllers work? Because Kubernetes controllers require you to understand how Kubernetes works. You need to work with their libraries, fight with their versions, and get it working. But what if anyone could just write such controllers without understanding how Kubernetes works? So I started off trying to standardize and simplify how you create these controllers. And what I mean by this is I was trying to make it just simple for someone who doesn't know Kubernetes but is from an IT background to start using this. So in order to standardize this, the first question that comes up always is, how are you going to model every application on the planet? PostgreSQL is different from, say, Kafka or MySQL. How are you going to manage this? And after spending about a year and a half thinking about it, I I finally came up with actually a really simple modeling paradigm. Every application actually follows a state machine, and you can model it starting from a deploy state and ending at an end state, and they go through an arbitrary set of states in the middle. This is the state machine for the PostgreSQL that I just deployed. It starts at deploy. You can backup, you can restore from a backup, and then it goes to active, or you can directly go to active on a fresh install. You can upgrade, where upgrade can be done in a blue-green fashion or a rolling upgrade fashion, and then you can come back to active state. And then once you're done using it and you want to decommission it, it can be brought to the end state. So given that any application can be modeled this way, I wanted to come up with a specification language so that people can just use a YAML syntax and start modeling their applications just the way I ran PostgreSQL. So let's just look at how deploy works in PostgreSQL, and I'll talk about how I modeled it later. So the way deploy works is there are a set of hosts, and these hosts run PostgreSQL. I've divided these hosts into two availability zones for high availability, and the master replicates with the slave in the same availability zone in a synchronous fashion. A synchronous replication is where if you commit a write or a transaction to the master, it's not considered successful until the slave also finishes the commit. And then there's asynchronous replication across availability zones. This is asynchronous, which reaches eventual consistency, and this runs on a different availability zone. So in Kubernetes today, if you've tried launching pods, it is possible to make a specific pod run on a specific host. It's easy to choose it based on labels, based on affinity. There's a lot of ways to do it. But if you did that, what you end up doing is tying your Kubernetes pod definition or this PostgreSQL's definition to the actual infrastructure. There is currently not an easy way to write a definition for an application that just runs on any cluster or any infrastructure. So what I did, I created this concept called abstract hosts and grouping. So what this does is, while you're writing the definition, while application definition writing time, you don't have to know what are the underlying hosts. You can just deploy this pod on a host group 1 or host group 2. And during runtime, this host group is mapped to actual hosts. That way, whatever you define becomes infrastructure agnostic. So that's what I've defined as an abstract host. It enables the creation of infrastructure agnostic application definitions. So what does this give us? So given abstract hosts and given this concept, the next step is trying to understand why this matters. So this is the definition, a Kubernetes definition. It's an actual pod spec without any decorations on it for just launching the master pod, the PostgreSQL master that I just launched just now, and it chooses the zone in which it should be launched. It says zone equals AZ1, and it mounts a volume and it runs two different pods, and this is the volume definition. I would say this file is complicated. Wouldn't you agree? This file is not the easiest to read and understand. So what I did was I created something called as a shorthand syntax for it. A shorthand syntax, it's a syntax that represents Kubernetes resources just the same, but it makes it easier to read. It has a one-to-one mapping to actual Kubernetes resources. There's no extra things you need to learn. If you've been using a pod, you continue to use a pod, but the way you define it is much more readable. The same definition which you saw in the previous slide is here. The same semantics are here, but it's much simpler to look at and read and understand. So let me go into, for example, this portion of the original definition. This portion, all it does is just one function, which is say that pod runs in a host that has zone set to availability zone 1. That's all it says. And this is really complicated looking. And in the shorthand syntax, it's just that. You just choose the abstract host that you want to run this on. Second thing is look at how volumes have been defined. So Kubernetes requires you to specify volume mounts in 2 places in the same file, and this leads to files that easily become unmanageable. We end up with really large files, and as you start writing more files, you end up managing so many files and you don't know where errors exist, and it's hard to just go through the file system and try and understand where things are going wrong. So I came up with this concept of imports. So in this shorthand syntax, you can import another YAML file, and using the import, what happens is you can easily mount the volume from the imported file, and also it lets me do correctness checks on it. So in the original file, if you created a persistent volume and if you ran the pod, it would work, but if you forgot to create the persistent volume and you try to schedule the pod won't get scheduled. But in this, I can reason and say, okay, this requires a persistent volume to be created. It'll go check if persistent volume exists. If not, it creates it. So just to recap everything that I just talked about, I first showed you the application automation of PostgreSQL, and then the shorthand syntax. The shorthand syntax just improves readability and is simpler to work with. The second thing was that it is completely Kubernetes native. There are no new concepts to learn. If you understand and know Kubernetes already, you can already use this. It's a completely declarative interface. It is cluster and infrastructure agnostic. So if you create a PostgreSQL definition in your cluster, you can easily transfer it to someone else's cluster and it'll just work. The last is the state management and other powerful features, which we saw in the demo. But at this point, I've cut the presentation short at this point. But if you're interested in learning more about it, I've called this project Project Koki. And I would love for everyone to go see it and add issues, contribute. Everything is welcome. We want people of engineering background, sales background, everyone to just come and take a look and make suggestions or make contributions. Everyone's welcome. And finally, just before I finish off, yes, you can follow me on social media. My Twitter handle is utterbabbage. My GitHub is wlan0. I am a Kubernetes core contributor and I maintain the cloud controller parts of it. I'm also a Docker contributor. I wrote the log driver framework in Docker. And I'm also the founder at a small company called Caascade, which works on this. We would definitely like for everyone to reach out. And if you have any questions about what I just showed you about Koki, about application lifecycle management, and if you'd like to see a demo, you're really welcome to do that. Thank you.